Supernovas are a big, giant, dramatic end to a star's life.
For a star to go supernova, we think it has to be at least 8 times more massive than our sun.
Betelgeuse, the iconic red supergiant, might not be as lonely as we thought. Recent research suggests it could have a companion, a hidden stellar buddy quietly influencing its fate. This discovery could rewrite what we know about Betelgeuse, including whether its long-anticipated supernova is as imminent as we once believed. Could this cosmic partnership be the reason behind Betelgeuse's mysterious dimming and pulsations? And more importantly, does this mean the universe's next great light show is on hold? Betelgeuse, the celestial superstar. Betelgeuse isn't just another star in the night sky, it's a legend. Positioned as the bright red shoulder of Orion, Betelgeuse is one of the most recognizable stars visible to the naked eye. Its fiery hue and immense size make it stand out among its celestial peers. But what really catapulted Betelgeuse to stardom? For starters, it's a red supergiant, one of the largest stars we've ever observed. If Betelgeuse were placed in our solar system, its surface would extend beyond the orbit of Jupiter. That's how massive it is. But size isn't its only claim to fame. Betelgeuse is also nearing the end of its life cycle, and for decades, astronomers have speculated about its fate. When stars this massive run out of fuel, they collapse under their own gravity and explode in a brilliant supernova. Given its proximity to Earth, only 427 light-years away, such an event would be spectacular. Imagine a star so bright it could be seen during the day. Yet recent findings hint at a twist in this cosmic story. Betelgeuse might not be the lone giant we've always thought it was. A smaller companion star could be lurking nearby, and its presence could rewrite the timeline for Betelgeuse's explosive finale. Intrigued? Let's dive deeper. The Great Dimming, a star's mystery moment. In late 2019, Betelgeuse shocked astronomers and stargazers alike by dimming dramatically. This wasn't just a subtle flicker, it was a major drop in brightness, one noticeable even to the naked eye. Dubbed the Great Dimming, this phenomenon sparked a frenzy of speculation. Many believed this was it, the final act of Betelgeuse before it went supernova. Headlines screamed about the impending explosion, and telescopes worldwide were trained on the star. But as months passed, Betelgeuse returned to its usual brightness, leaving scientists scratching their heads. What caused this mysterious dimming? The answer, it turned out, wasn't as dramatic as a pre-supernova event. A giant dust cloud formed near Betelgeuse, temporarily blocking its light from our view. This explanation might have satisfied some, but for others it raised more questions. Why was the dust formed in the first place? Could there be more to Betelgeuse's behavior than meets the eye? This is where the theory of a companion star comes in. Could a smaller star in a binary system with Betelgeuse be influencing its periodic dimming and brightening? A stellar buddy? The binary star hypothesis. The idea that Betelgeuse might be part of a binary star system isn't new. Astronomers have suspected this possibility for decades, but recent studies have provided compelling evidence. A trio of researchers recently analyzed Betelgeuse's light curve, the pattern of its waxing and waning brightness, and discovered a peculiar 2,170-day cycle. This long secondary period isn't unusual for stars like Betelgeuse, but the cause of such cycles is often linked to binary systems. In simple terms, the hypothesis is this: Betelgeuse has a companion star, roughly 1.7 times the mass of our Sun. As the two stars orbit each other, the companion's gravitational pull creates fluctuations in Betelgeuse's outer layers, influencing its brightness. What makes this discovery particularly exciting is how it changes our understanding of Betelgeuse's timeline. If the smaller star is indeed interacting with Betelgeuse, it could be delaying the supernova we've all been waiting for. How do binary systems work? Binary star systems are incredibly common in the universe. In fact, many of the stars we see in the night sky aren't single stars but pairs, or even trios, bound together by gravity. In a binary system, the stars can have a variety of relationships. Some orbit each other closely, transferring mass between them. Others maintain a more distant relationship, like two celestial dancers keeping their distance, but still moving in sync. If Betelgeuse is part of such a system, its smaller companion might be playing a significant role in its behavior. For example, the companion could be responsible for the dust that caused the Great Dimming. As the two stars orbit, the gravitational interaction could generate massive stellar winds, carrying material from Betelgeuse into space. This material might then cool and condense into dust, temporarily blocking the star's light. But the implications go beyond just explaining the dimming. A companion star could also influence Betelgeuse's internal processes, potentially delaying its evolution into a supernova. Supernova. Soon? Maybe not for years. Scientists have been predicting that Betelgeuse could go supernova within a few dozen to a few hundred years. But if it's part of a binary system, that timeline might be far too optimistic or pessimistic, depending on your point of view. Here's why. The presence of a companion star could mean Betelgeuse is still in an earlier phase of its life cycle. Specifically, it might still be in its core helium-burning phase, a stage that could last for hundreds of thousands of years. Without a companion, Betelgeuse's 2,170-day cycle might indicate that it's already burning carbon in its core, a precursor to the final collapse. But if this cycle is instead influenced by the companion's orbit, it suggests a much slower evolution. For those of us hoping to witness a supernova in our lifetimes, this news might be a bit disappointing. But on the bright side, it means Betelgeuse has more time to teach us about the life and death of massive stars. The science behind the hypothesis. How do astronomers determine whether a star like Betelgeuse has a companion? One key method is analyzing the star's radial velocity, the movement of its surface toward or away from us. If a companion star is present, it can cause subtle shifts in this velocity, detectable with modern telescopes. Another clue lies in the star's light curve. The 2,170-day cycle observed in Betelgeuse's brightness doesn't align perfectly with its radial velocity variations. This out-of-syncness could be explained by the gravitational influence of a smaller companion. Finally, there's the role of dust. If the companion star is contributing to the formation of dust clouds, it could explain not just the Great Dimming, but also other irregularities in Betelgeuse's brightness. What's next for Betelgeuse? While the idea of a companion star is exciting, it's far from confirmed. Future observations will be crucial in determining whether Betelgeuse truly has a stellar buddy. One promising avenue is the James Webb Space Telescope. With its advanced infrared capabilities, Webb could provide a clearer picture of Betelgeuse's surroundings, potentially identifying a smaller companion or revealing more about the star's dusty environment. In the meantime, Betelgeuse remains a fascinating subject of study. Whether or not it's part of a binary system, this iconic star continues to captivate astronomers and stargazers alike. What if Betelgeuse goes supernova? Let's indulge in a bit of speculation. If Betelgeuse were to explode as a supernova tomorrow, what would it look like? For starters, it would be incredibly bright, so bright that it could outshine the full moon and be visible during the day. The light show would last for weeks, followed by a gradual fading over months. Astronomers would also have a front-row seat to study the physics of a supernova in unprecedented detail. Such an event would provide invaluable data, helping us understand the life cycles of massive stars and the origins of elements like iron and gold. But for now, it seems Betelgeuse's explosion is more likely to be a distant spectacle, one for future generations to marvel at. Could Betelgeuse's buddy be a black hole? Here's a twist for you. What if Betelgeuse's companion isn't a star at all? Some astronomers have speculated that the hypothetical buddy could be a black hole or a neutron star, remnants of a previously exploded star that once shared the system. This isn't as far-fetched as it sounds. Binary systems with massive stars often result in one partner evolving faster, collapsing into a black hole or neutron star, while the other continues its life cycle. If Betelgeuse's companion is indeed a compact object like this, its gravity could have profound effects on Betelgeuse. For one, a black hole companion could be siphoning material from Betelgeuse, creating a disk of hot, glowing gas that might explain some of the star's odd behaviors. Alternatively, if the companion is a neutron star, Its intense magnetic fields could also influence Betelgeuse's outer layers, creating instabilities that lead to dust formation and dimming. Detecting such a companion would be tricky but not impossible. The gravitational interactions would still leave their mark on Betelgeuse's light patterns, and high-resolution imaging from observatories like the Event Horizon Telescope might someday reveal more. A black hole buddy would not only delay Betelgeuse's supernova, but turn its story into a truly cosmic thriller. What Betelgeuse teaches us about the universe. Beyond the drama of potential supernovae and hidden companions, Betelgeuse serves as a vital laboratory for understanding the universe. Stars like this one are the factories of elements that make life possible. When they die, they scatter these elements across space, seeding the next generation of stars, planets, and even living beings. The study of Betelgeuse also highlights the incredible progress in astronomical technology and techniques. A century ago, we could only guess what stars were made of, let alone track their life cycles in such detail. Today, we can measure their pulsations, track their light curves, and even detect dust clouds light years away. Finally, Betelgeuse reminds us of the unpredictability of the cosmos. Despite all our knowledge, we can't say for sure when it will explode or what secrets it's hiding. That's the beauty of astronomy. It's a field that constantly surprises us, revealing new wonders with every observation. So whether Betelgeuse has a buddy or not, it continues to be one of the most intriguing stars in the sky, capturing our imaginations and expanding our understanding of the universe. Betelgeuse has always been a star of intrigue, and the possibility of a companion only adds to its mystique. Whether or not it's part of a binary system, this iconic red giant reminds us of the complexity and wonder of the universe. So, is Betelgeuse's supernova postponed? For now, it seems so. But one thing's for sure, this cosmic drama is far from over. And as we continue to study this fascinating star, who knows what other secrets it might reveal? What do you think about Betelgeuse's cosmic buddy? Could it really delay the supernova, or is there more to uncover? Drop your thoughts in the comments. We'd love to hear your take on this stellar mystery.